Okay, can we start? Good afternoon, everyone. Welcome to the session of Igor Derman. Hi, Igor, you can open your microphone. And the session is building Ethereum dApps with .NET and Azure. I think it is very interesting session. Igor, if you are ready, you can start your session.
Sure. Thank you, Luca. Yes, we can start. Okay.
Thank you.
So welcome everyone, and thank you for attending. My name is Igor, software engineer, and I mostly work in Microsoft technology stack. Today, I will speak about how to, start building dApps on Ethereum using .NET and Microsoft tools in general. Why this topic? Because Ethereum dApps is something which is, very interesting in these days, and it's basically it's a rising area. And as you know, for technology stack for Ethereum, dApps are mostly oriented to open source tools, some other languages. And but I want to show you that .NET can be used for building such apps. And main goal actually of this presentation is to show where to start. So someone who want to move from centralized to decentralized application, I want to show where is entry point for that. Okay, let's quickly take a look at our sponsors. Thank you. And about agenda of today's topic, we have to speak a bit about.
Igor,
yeah.
Sorry, can you put some PowerPoint to full screen?
Yes.
As a presentation mode. Thank you.
Thank you for suggestion.
I think the other. I think you have to share the other monitor if you have.
Yes, just a second.
Sorry.
No problem.
Otherwise, you can do as you did before.
For some reason, when I hit F5, it's. Do you see now? No. Okay.
It's better. Okay. Thank you.
Okay. No problem. Yeah, you can continue in this way. Thank you. Okay. So we will talk about blockchain in general. We have to give some introduction. What is blockchain and what are use cases and how to use it. Of course, we will then talk about Ethereum. What is Ethereum? Actually, is public blockchain, because there are a lot of blockchain network on the market, but at the moment we are focused on Ethereum. And we will talk about frameworks and tools which is used for development, and of course about .NET and Azure. In the end, we will have some conclusion. Of course, we will have a few examples in code. So we can start. Blockchain is buzzword nowadays in the world, and there are a lot of blockchains on the market. And what is blockchain? Blockchain, in short, is method of organizing data. From technical point of view, it's just some array of blocks which are connected by cryptography and contain data which are encrypted. Of course, there are some other networks, kind of networks, which are distributed like blockchain, but blockchain itself has, several unique features. It's used for the wide use cases, but first association for people is crypto market, tokens, coins, and so on. But it's just one side. blockchain can be used for a lot of different use case, and can be used in any basically in any industry, like supply chain, organization, government, voting, and so on. But it's resolving a lot of critical problems for the crypto. I will just mention only one. It's problem of double spending. There is always problem in financial application when you need to send some money, and how to prevent that you send in the next millisecond money to the second address and basically do double spend. This is successfully resolved using blockchain. So that's only one thing. This is this part is huge, and we will talk on it for hours of that. But this is just in short. Concepts of blockchains. We have transaction, immutable ledgers, decentralization, encryption, consensus mechanism, smart contracts. Let's talk very shortly about them. Transactions, obviously, all concept is based on sending ownership or something else from point A to point B. So everything is based on transactions. It's basically transaction system. Immutable ledgers means that data we have in ledger cannot be changed. Something which is written in blockchain, we cannot edit and we cannot delete. So this is very, very important. Of course, the whole network is decentralized, and that's one of the key concepts. And all data is encrypted. This is, let's say, pretty clear. Next, we have smart contracts. This is smart contract or contracts are a big difference between blockchain of first generation and blockchain of second generation. Blockchain first generation is, for example, Bitcoin network. In Bitcoin blockchain system, we have only Bitcoin as coin, and that's all. We don't have possibility to execute any business logic. Actually, we cannot build application on such a blockchain. But Ethereum is blockchain second generation. On blockchain, we have possibility to execute small pieces of code, which is called smart contract, and in that contract we can write business logic. We can write whatever we want using programming language. In case of Ethereum, that's Solidity, but in case of other blockchains, there are a number of languages which are used. Some of them are common used for other purposes, not only. But Solidity for Ethereum is only used for smart contract. All of these concepts are, let's say, common for all blockchains. But the main difference between different blockchains is consensus mechanism. It can be very, very different. Consensus mechanism, in short, is used for for validation. When we have a new block in the system, we need to somehow validate that block, and we use something called consensus for that, consensus mechanism. But at the moment, we have 10 or 20 different consensus mechanisms, and in theory, everyone can make own consensus mechanism. But in mainstream medias and news and so on, we are always mention proof of work and proof of stake. Proof of work is something called mining. It's a buzzword kind of better version of proof of work. We will talk a bit later about that. Before we jump to consensus mechanism, just very short about the block inside blockchains. In short, the block is just permanent store. In block, we can place something, and once written, it cannot be edited or deleted. Content data is encrypted. Every block includes information about previous block, so it contains hash of previous block. So if the previous block is hacked somehow, or is changed, or something happened, current block, we will know that something is wrong, and chain will be broken. Before editing new block in the system, we need to validate somehow. That's why we use consensus mechanism, actually consensus protocol for that. How it looks one block. This is just the illustration. It's let's say more complex of this. There is header and there is content. Header contains metadata of the block, and data basically is payload, which is can contain timestamp, transaction, list of transaction, and so on. Because in every chain has to start somewhere. So the first block in the blockchain is called genesis block, and it's a reference block for every next block in the chain. Okay. But how we can add a new block in the system? We have to validate it, and for the first couple of years of existing blockchain, mining was the only way. Mining is called actually is proof of work protocol. That means that some miner in the system, some node in the system, trying to find a valid hash, which is not easy task. And the first miner who finds correct hash, becomes the creator of new block, but also get some small amount of the coin. So that's why it's mining. It's in some way it's really mining, because you can find or not find hash. If you find, you will get some basically money for that. Actually coin. But what is downside of the proof of work? It's consuming a lot of energy, and it's not eco-friendly, and today is different than a couple of years. Today, if you do mining today, you need to spend a lot of more energy, and you will get a smaller amount of the coins. So basically, you don't have some profit on that. So people try to change that from proof of work to proof of stake. Proof of stake is different kind of protocol, where validation is doing based on how many coins you have. So nodes which have items in the network which have more coins than other will be called to validate transaction and so on. It's consuming a lot of smaller amount of energy than proof of work. And why this is important? Because at the moment there is people trying to change protocol on Ethereum network from proof of work and proof of stake. There were a couple of hard forks, and in the future, for sure, proof of stake will be only consensus mechanism on Ethereum network. Of course, we have a lot of others consensus mechanisms which are not so, let's say, popular, or maybe which are not widely used in applications, but they exist, and they are maybe efficient than these two protocols. And at the end, I can write my consensus protocol, or someone other can write some consensus protocol and put it in some private blockchain. Okay, let's go further. Before closing this session, just for complete explanation, just a few words about nodes. Basically, nodes are computers which are connected to the network. It's important to understand that we have a different kind of nodes. We have full nodes, which is actually contains data. We have light nodes, which are only for validated blocks. We have a mining node that produces blocks, and for example, we have a web node. We have to have web node because it's basically wallet, which is connected to the server. So I hope now we have better picture of what is blockchain is. And just to note that we have public and private blockchain. Sometimes it's hard to understand, but this is the same concept as cloud and on-premise. We have a number of public cloud, let's say. It's blockchains like Ethereum, Solana, or subchains on Ethereum. But we also have a lot of private blockchains. Maybe the most known is Hyperledger. Hyperledger actually is foundation which contains a lot of different open source blockchain frameworks, and it is important to understand that every concept, public or private, has upsides and downsides. Of course, maybe for some development and Web3 applications and the apps, it's easy to connect to public blockchain and store and consuming data. But you can also run your own blockchain network on your own servers. It's more work, and it's not easy to do. But in that case, you will have full control. For example, you can change anytime consensus mechanism in your blockchain, or maybe you building some application for the bank, and bank just doesn't want to be public. Maybe you are building some internal system for in-house or something like that. So private blockchains are important. There are a lot of different, and like public, they have upsides and downsides. For going to Ethereum, just quick small table. It's a bit old from before a few years, but it's still actual. So this is small comparison between Ethereum, which is public, Hyperledger public, which is private, maybe the most popular private blockchain, and R3 Corda. It's old blockchain which is used only in financial industry. And if you compare some items here, you will see, for example, consensus. Ethereum used and use today in some way proof of work, and for Fabric you can turn on and turn off different consensus mechanism, and RT Corda has own consensus mechanism. Also, if you look to smart contracts, you will see that for Ethereum use Solidity, but for example for Hyperledger Fabric you can write in Go, Java, and JavaScript. It's not on the list, but you can write a smart contract in JavaScript, which is actually good because JavaScript is widely used. So also it's important if you compare currency. Ethereum has own well-known currency Ether, and of course you can create token via smart contract at any moment, and Hyperledger actually doesn't have currency, but it doesn't have coin actually, and but you can create token at any time. Okay, that was enough for blockchain. Let's say a few words about Ethereum. In short, it's a blockchain like others, public database, and implements blockchain paradigms. But what's different in Ethereum? Actually, if you look to the picture at the right, you will see how layers are going. We have peers, blockchain, smart contract, token. But if we imagine a Bitcoin network, we will see that in Bitcoin network we have only peers and blockchain. We don't have smart contract, and as consequence we don't have token. That's the big difference. Because in 2016 when Ethereum launched, it had a possibility to put your own business logic to smart contract and execute it, and was game changer for this industry. Of course, because this is public network, nothing is free. So basically, for a transaction, you have to pay. It's that fee. It's called gas. It's variable. So it's change depend of power or number of transaction and so on. But it's important. It's important variable if you building something. For example, let's say you are building marketplace for NFT or something like that, or selling something on the website, and you're storing that data or NFTs, whatever, in Ethereum blockchain. For every transaction, you will pay something. So you have to calculate that in price. So other ways you will not have profit at all. So it's important to understand the concept that it's public. It's public, which means it's not free. At least it's not completely free. As I said, Ethereum has own crypto wallet, and it's called Ether, but also have a way. It's some kind of internal value, and usually these transactions are exposed in way, but later in code we will see how it's easy to convert that in Ether. Okay, let's go footer. As I said already this, the Ethereum blockchain was not created to support cryptocurrency. It's created to provide possibility to build application which is based on Ethereum blockchain. So this is as I said, it's game changer. It was game changer at that time, few years ago. Okay, but let's talk about frameworks, our favorite topic, about code and frameworks and tools. First of all, because this session is connected to Ethereum, we need to focus on what is used for Ethereum. As I said earlier, for writing smart contract, it's used Solidity. It's object-oriented programming language, and it's it's very small language. It's not so hard to learn Solidity, but Solidity is just one puzzle in the whole pictures. Also, please note that Solidity is used for Ethereum, but also it's used for some other blockchain systems. So if you invest, time and energy to learn Solidity, you can write contracts not only for Ethereum, but for other blockchains as well. From technical speaking, it's code which is executed on Ethereum virtual machine. It's similar concept like Java, for example. Here we have very small example, minimal example of Solidity. It's classical. There is some syntax and variables are strong typized. Also pay attention to pragma solidity statement at the beginning, because it's Solidity contract always has a pragma solidity statement which defines on which version this code can work in a matter of compile. So it's important to know what is compatible with what. Also, my favorite topic. When we said dApps, current applications are not completely decentralized, because today we still have to provide to the customer some front end. We have to send something to browser and show to. So basically, at the moment, we still need to use some kind of website, web portal, HTML, CSS, JavaScript. It's we have to have some front end. Backend, maybe we will have backend, maybe not. It depends, because maybe we need to store some data not on the blockchain. Maybe we need to store something in classical database. Why? Because storing data on blockchain costs. So maybe and we want to save, for example, user profile or some user settings or something like that. If you want to do that, in that case, we will have some kind of backend. So we have front end, we have maybe backend, maybe we have database, not blockchain, but classical database, whatever kind of database it is. And that means the whole that part, it's called off-chain. It's outside the chain. When we say on-chain, we thinking about the part which are on blockchain, And today we are still somewhere in the middle. We need on-chain, we need off-chain, and there is bridge between, which is exactly this smart contract, which represents business logic, which is executed on the blockchain, on the blockchain network. So basically, it's important to understand that we are still dealing with classical technology, but we need some libraries and to connect to this on-chain part. And at the market at the moment we have a lot of libraries, but not for .NET. For .NET, offer is very limited. Okay, let's go further. Okay, about very short about some highlights about tools. If you're learning and coding with Solidity, we can use Remix. It's in browser integrated, environment, and it's very easy to use. So you don't need to install something on your computer. Just make some example in Solidity. Just copy paste to Remix in browser and execute it. So it's very It's very useful. OpenZeppelin, it's very popular libraries for writing contacts in Solidity. Etherscan actually is tool, online tool, where you can track transaction on Ethereum blockchain. So very useful to check if something executed or stuff like that. And Truffle actually is it's the whole framework for development contract and for writing tests. Okay. And what about that was about that middle layer connection between on-site and off-site. And what about frontend? Because JavaScript is widely used today as vanilla JavaScript or as React or Angular or Vue or whatever framework we use. Obviously, we need some library for JavaScript library which will ensure connection between your frontend and smart contracts on blockchain network. The two the most popular are Web3.js and Ether.js. I'm sure you read something about it. Also, TypeChain is just a tool for generated types actually contracts, and Web3 React. Okay, that's small tool specific for the React environment and very useful to connect your React application to the wallet. Okay, that was JavaScript. But what about .NET? I guess we are mostly here working in Microsoft technology stack. And for example, I'm working in .NET for 15 years, something like that. So I was interested how can I connect C# code to the Ethereum? Unfortunately, we don't have so much alternatives. We have an Ethereum library. It's .NET integration library, and very easy to reference it. We will see it a few minutes later, and it's well supported and it's under development all the time. We don't have some other alternatives like Ethereum. We have a smaller libraries which are, frankly speaking, not so good like Ethereum. So if you want to start developing something in C# and connect that to Ethereum blockchain, you have to use an Ethereum library, and you don't have so much choice here. There is great on main Ethereum org website. There is one section for .NET developers. It's basically on entry point, main point for .NET. Also in Ethereum itself has fantastic documentation, so with a lot of examples, with a lot of examples and so on. Okay, and before talking about Azure, we will jump in code and show in how it looks in practice. First, I prepare here one basic example with an Ethereum bibliothèque. If you look to the solution, and if you look under packages, you will see that I made reference to Ethereum .web3 package, and for some start, that's all we need. Why? Because Ethereum library is huge and has a lot of interfaces and APIs for connection to the blockchain functions. And let's imagine that we have some .NET application, and which are actually is not Web3 application, is not decentralized, but we want to read some amount or some wallet or something like that on the internet and show that data on the screen. This is let's call that method get account balance. So basically we have some account. This is address of the account, and we want to read from the mainnet from the Ethereum and see how many ethers has on that account. We don't know which his account is because it's anonymous, obviously, but we have address. And let's zoom a bit. So first, we will make instance of Web3 Ethereum class. That's important. But if you pay attention, I provide here some URL. And that URL is actually third-party service Infura. Why Infura?
Igor,
yeah.
Can you zoom? Yes, a little bit. Okay, thank you.
Okay, great, thank you. So why Infura? Infura is third-party service. It's used for reading something from blockchain network, and basically you don't have pay for that. Why? Because in this case, we don't have a reason to build some some code and connect directly to RPC or blockchain and read something, because we will have to pay some provision for that. But in this case, we will use Infura, and Infura is service. We will register itself on the service and get some token. Actually, this one is my personal token on Infura, and we will provide that too. So it's basically free until some number of requests. Of course, with with increasing number of requests, you will have to pay some subscription or something like that. But for for the smaller amount of requests, it's free. Also, so after initialization of Web3, we call just get balance and give it address of the SAM wallet, and we will get a result in way. It's internal value for the Ethereum, and I will convert it on in Ethers itself. Okay, let's run it to happen. Okay, we don't have exceptions, so basically this works, and we get some amount in ways, and we have 352,068 Ethers in this account. It's huge. It's huge. Actually, this is address of Ethereum. This is wallet of Ethereum Foundation itself. So that's why so many Ethers it's stored here. I mean, this is public info, so you can read it from the blockchain. So in case when we have classical application and just want to fetch something from blockchain, some information and show it somewhere, we can use Infura or some other third-party service, and without cost, free. We can read it and show it. So basically, the only mandatory thing is using Ethereum wallet. Okay, this was very simple example. Let's take other example, which is more complicated and actually doing connection to some blockchain and execution some transaction. Before I jump to this, I will show something else. This is Visual Studio Code. We were in Visual Studio now in Visual Studio Code. Why is Visual Studio Code? We mentioned that when we writing Solidity contracts, we have to use some tool. Of course, there is other tools for which are specialized for Solidity, but Visual Studio Code is good as well for these purposes. Here we have one sol file. It's simple. It's very simple Solidity contract. It has set to get. That's all. So if you want. So for C# we use Ethereum library, and for the Solidity we can use Visual Studio Code with installation of of course some few extensions. We don't have to install it, but if you want highlight code and compiler to work, we have to install it there. So at the moment I have here just this Solidity. It's some kind well supported of plugin for Visual Studio, and that's basically all we need. Okay, let's go back. Here is code, and what happened when we hit F5? Okay, compilation completed successfully. Okay, we have some warning. It doesn't matter. It's something about license, and we didn't see. But what happened? This file with extension ABI is changed. Actually, it's some final result of the compilation Solidity code. Why that is important? If we now jump back to .NET example, you will see. Let's expand this. You will see one package here. In this solution, we install Ethereum Web3. It's used in the previous example, but also we install something called Ethereum Autogen Contract API. And it's why that's important, because this package is searching for these ABI files and making and generating contracts from them. So basically, this service here is partial class. It's a result of this, but conversion was done by this Ethereum Autogen contract API. Why that is important? Because we get here, written service. We just need from C# code to call these methods. So in main part of program, in our case, it's this program.cs. We will just call this service. It's auto-generated based on our Solidity contract. Okay. So I hope that's connection between Solidity and the .NET code is clear. And of course, we like in previous example, we have here some initialization of some classes which need. One of them is again Web3. No, but before we also need to to make initialization of account class. If you pay attention, I put here one local host address. Actually, it's address from local blockchain networks. This is something called Ganachi, an extremely useful tool. It's application you just install on your computer if you are on Windows and run it, and you will get some fake nodes and accounts and some fake balance, and basically you can use it for testing on your local environment. Because if you send something to mainnet or network, you will pay provision for that. You will pay transaction. So when you are in development phase, obviously you have to test this on local environment. But there is a couple of these tools, but I use Ganachi. It's very simple and works fine. On the main screen we have here RPC server. It's basically this address. Also we have something called network ID or train ID. This is important for initialization. And also we have 10 or 20 accounts which are auto-generated, and we can open it and copy private key from them. All these data are necessary to make, to connect our application to our local blockchain network. This is RPC server. This is private address. This is chain. If this is fine, basically we are connected to blockchain. Okay, and we have some initialization of our service here and calling some methods. Basically, we just want to, execute one simple transaction and to see and compare results at the end. We want to send 42, and we expect that after, getting value back, via get query async, we will see that transaction is executed and the result really 42. Okay, we are running out of time a bit, but I'm finishing soon. Okay, this is good actually. This works. In case if we have issue with connect something, we will get exception here. So this is deploying actually successful. We find that contract address on this. This is actually this one address. So we will find it on local blockchain network. We will store some transaction, get status 7, which is successful. And then what we do next, we send a request to check balance of that account and get it's 42, and we are sent it's 42, and we expect that it's really 42. So basically this is small amount, small example, but and small amount, but we see that we can easily send it from C# code, and this is example how to send transaction and get a result back. And because we are running with time, let's quickly about Azure. What about this is for the local environment? What about Azure? Well, if you go to Azure portal, I'm already logged in. We will see that by default we have some blockchains templates for creating blockchain network on the cloud. Before we had a lot of these templates. For some reason, Microsoft removed some of them because it's question about concurrency and so on. So, but now if you go to marketplace on the if you go to marketplace of Azure, and if we and to try to find something connected to sorry. Okay. We will see that we have a lot of third-party extensions for the Azure. That means we have 3 possibilities. One possibility is to run virtual machine on Azure and set our blockchain, itself. Second option is using some of existing Azure templates for building, but as I said, it's very limited at the moment. We don't have so much. For example, a great template for Hyperledger Fabric is removed 2 years ago. And third option is go to marketplace and see what we can get. For example, let's say this one, Ethereum full node. This is actually a template which we can create full node for Ethereum network for Ethereum network, but on Azure, which is pretty interesting. So instead of setting the whole virtual machine and making node, we can use this template and set it in a few minutes. Also, we can use every of these templates and create network and using development locally, and that after that deploy that to the Azure. So basically, Azure has its place. If you want to play the ground, if you play with Azure in the matter of blockchain, there is free account, so you can try basic stuff. Okay, Luca, sorry, it was a bit longer than but
it doesn't matter.
Okay. So basically that's all from me. Also, there is a lot of on this topic, there are a lot of tutorials on internet, so you can expand your network. But just remember that if you want to start with .NET development, find Ethereum library, install Solidity extension to Visual Studio Code, and you can use Visual Studio and Visual Studio Code together, and forget to code generation and services, it will be generated automatically, and you can focus on the business logic and so on, and make your application connected to Ethereum. Okay, Luca, basically that's all from my side. Sorry for the time.
Okay, there are no questions.
Mm-hmm.
I have just a question. If there are some samples on GitHub, on your GitHub account or something else, some projects.
And,
Do you have any public samples?
I have one important project, but it's not public at the moment. But I want to public one actually what written is in this, which is pretty interesting. So I can share with it after you publish it if you want, if that's useful.
Okay. So Igor,
yep.
I have to say thank you. Okay. Thank you for the interesting session, and see you next time. I hope so.
I hope so.
Probably, I hope in person for in-person session.
Yes, that will be great.
As everybody now is in person, we hope that we can do it as soon as possible. And so I just yes. An attendee asked if it's possible to have the slide. You can share the slide. If you can send the slide to me, I also in PDF. There's no problem. I can add it to the video that we will public on our YouTube account.
Okay. In that case, I will send it to you directly.
Okay. Thank you. Also in PDF, it's not a problem. Not only PowerPoint. Okay.
Okay. So it's PDF. Okay. No problem.
Okay. As you prefer. No worry.
Okay.
Thank you.
Thank you.
Thank you. See you next time. Bye.
Next time.
Bye.
Okay. Cheers. Bye.